Hello, I'm Suki. If you don't know me, then on behalf of my dad, now you do. Let us begin this thing I have created. Okay, for my example, I will be using cellular respiration. It's an easy equation and I like it. First thing you're going to want to do is count how many carbon, hydrogen, and oxygen are in one equation. When counting on the left side, we get 6 carbon, 12 hydrogen, and 8 oxygen. On the other side of the equation, we have 1 carbon, 3 oxygen, and 2 hydrogen. We see that on the right side that there is only 1 carbon, which is in CO2. And on the left side, we see that there is 6 carbon. So what we do is we times something, which is 1, by something else to get 6. So 1 times what is 6? We should all know this. This is easy. It's 6. So we would put a 6 in front of the CO2. Doing this will also multiply the O2 in CO2, which will give us 12 oxygen. So now, on the right side of our chemical equation, we should have 12 oxygen. Because there's a lot of O2 in this equation, we'll just leave the O2 alone until we're done balancing the carbon and the hydrogen. Speaking of balancing hydrogen, let's work on doing that next. On the left side, you can see that there is 12 hydrogen. In order to balance that out, we're going to have to multiply something by 2 in order to get 12, which again would be 6. So you're going to put a 6 in front of the H2O to get 12 hydrogen and 6 oxygen. So now, on the right side of the equation, we have 18 oxygen, and on the left side, we have 8 oxygen. To balance it, we had to figure out what we need to add to 6 to get ourselves 18. So what we would do to find that answer, we would subtract 18 and 6, which would in turn give us 12. So what we would do is we would have to times 2 by something to get 12, which would again be 6. And there you go. Just like that, your equation is balanced. And if you want to, you can add a 1 in front of C6H12O6, but it's not exactly mandatory.
Hey, oh, I am alive, oh, live off alive, oh, you're the creator, you're traitor,